Hi YouTube, Tim Unkert here. In this video, I'm going to cover my Intro to Logarithms quiz in Algebra 2, so let's get started. In this first problem, we have a log with a base of 3 of 27 equals x. So what we want to do is solve for x here. So first thing, I'm going to rewrite this in exponential form. So I'm going to write 3 to the power of x equals 27. And so what we're really looking to see here is how many 3's do we multiply together to get 27. So let's check it out. So if we do 3 times 3, that's 9, times 3 again, that's 27. So we have 1, 2, 3 3's. So 3 to the third power equals 27. So therefore x equals 3. Okay, so that's problem 1. All right, problem 2, we have a log with a base of 4 of 32 equals x. We want to solve for x. So we could start off and try and set this up and say 4 to the x equals 32. And then we're going to look for how many times we multiply 4 together to get 32. So if I do 4 times 4, that's 16. But if I multiply by 4 again, it overshoots 32 and goes to 64. So we really want to use something called the change of base rule. So I'm going to say log with some base c, that I'll pick in a moment, of 32 over log with some base c of 4. Well, that's going to be what x is going to equal. Okay. Now we want to pick a base where we can multiply that base by itself enough times to get both 32 and 4, if possible. It's not always possible, but in this case it is. If we pick 2, that'll work. So we'll do log base 2 of 32 over log base 2 of 4. Okay, so log base 2 of 32, we have to pick out the number of 2's we have to multiply together to get 32. So if I start working it out, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So we have 1, 2, 3, 4, 5 2's that we multiply to get 32. So we have 5 on top over. We have to pick how many 2's we multiply together to get 4. So if we do 2 times 2, well, that's 2 2's. So we're going to put 2 on the bottom. So our solution is 5 halves, or you could write 2.5. And we're done with that one. Okay, this next one, we're going to evaluate log base 27 of 1 over 81. So we're coming up with a value here. If we were going to write this in exponential form, we'd say 27 to some power, I'm going to put a little question mark here, equals 1 over 81. And that's really going to be tough to figure out. So what we're going to do is also the change of base rule here. So we're going to say log with some base c of 1 over 81 over log some base c of 27. That's what we're going to need to figure out. Now I want to pick a number that can multiply by itself to get 81 and also 27. And that number happens to be 3. So I'm going to do log base 3 of 1 over 81 and over log base 3 of 27. Now we got to figure out how many 3's we multiply together to get 81. So let's start. So if I do 3 times 3, that's 9. Times 3 again, that gives me 27. Times 3 again, that gives me 81. But I have 1 over 81 here. And I have a video in here on negative logarithms. So you might want to watch that. We talk about negative exponents. But instead of 1, 2, 3, 4, so instead of putting positive 4 on top, we're actually going to put negative 4. And that's because of the nature of negative exponents. Again, I have a video on that on my channel, so check that out if you're confused on that. For the bottom part here, we have log base 3 of 27. So how many 3's do we multiply together to get 27? Well, that's these first 3. 3 times 3 is 9. Times 3 again is 27. So we have 3 3's here. So our solution is negative 4/3 for number 3. All right, next one, we're evaluating the log with the base of 1/4 of 1/64. So what that's asking me is what power of 1/4 equals 1/64. Another way to phrase that is how many 1/4 do I have to multiply by themselves to get 1/64? So I'm going to do 1/4 times 1/4. That's going to give me, 1 times 1, the top stays 1, 4 times 4, bottom 16. So 1/16. Okay, let's multiply by another 1/4. Top is still 1, 4 times 4 is 16, times 4 again is 64. So this equals 1/64. And I have 1, 2, 3 1/4 I multiply together to get 1/64. So my solution here is 3. Okay, let's keep going. Next one, we're evaluating log with the base of 3 of 120. So again, that's asking us 3 to what power equals 120. And this is something that would be very difficult to figure out because if we do 4 3's multiplied together, we get 81, and then 5 3's multiplied together is 243. So we're overshooting 120, so it's somewhere between 4 and 5 is the number we should get here. And to figure that out, we're going to use the change of base rule. So normally we'd say log with some base c of 120 over log with some base c of 3. So I could put 3 because 3 to the first power is 3. But again, I can't get 3 to any power to get 120. So we're actually just going to use the regular log, which is base 10. But we're going to put it in a calculator and come up with an approximation. Log 120 over log 3. And so I'm going to need to get out my calculator to do that. So let's pull out the calculator here. And we're going to do log 120 divided by log 3. And we get 4.357. I'm going to round it to 4.36. You may have rounded it differently on the quiz, but if you're watching from someone who took the quiz, I don't really care that much about that as long as it was close. So yeah, approximately 4.36. Okay, let's look at the next one. Okay, log base x of 81 equals 4, solve for x. So let's write this in exponential form. So we do x to the 4th power, so base of x to the power of 4, that's going to equal 81. Okay, so what I would encourage you to do is try out the numbers. So if I do 2 to the 4th power, I know 1 to the 4th power is going to be 1 because you're just multiplying by 1. So 2 to the 4th power, well, 2 times 2 is 4, times 2 again is 8, times 2 again is 16. That's too low. So 2 is not going to work. Let's try 3 to the 4th power. So 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So in this case, 3 to the 4th power is going to equal 81. So x is going to be 3. Okay, let's try another one. Problem 7, log base 5 of x equals 2. Solve for x. So again, we'll write this in exponential form. So we'll do the base 5 to the power 2 equals x. 5 to the second power is 5 times 5. Another way you might hear that being phrased is 5 squared. So 5 times 5 is 25. 25 equals x. Okay, let's keep going. Problem 8. Log base 7 of 1 over 49 equals x. So again, rewrite in exponential form. 7 to the x power equals 1 over 49. So first think, how many 7s do you have to multiply together to get 49? So 7 times 7 is 49, so just 2 7s. But again, this is 1 over 49, so instead of a positive 2 for an exponent, we're going to make it a negative 2. So 7 to the negative 2 power is 1 over 49. So x equals negative 2. Okay, and we're good with that one. Let's keep going. All right, problem 9. Log base 2 of x equals 5. So this is slightly different, even though we had the same numbers, but just rearranged. So we're going to write in exponential form. The base this time is 2. The power this time is 5. That equals x. So that's essentially 5 2's multiplied together. So 2 times 2 times 2 times 2 times 2 equals x. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So x equals 32 in this case. All right. Last one, log base 64 of 32 equals x. So again, we could start writing in exponential form. 64 to the x power equals 32. But you're going to quickly see you want to use change of base on this particular problem. So let's do that. We'll say log some base c of 32 over log of some base c of 64. That's going to be what x is going to be. So we want to pick a base here that's going to work. So I can multiply enough 2's to get both 32 and 64, so I'm going to choose a base of 2. So we have log base 2 of 32 over log base 2 of 64. If you think about this, from the last problem we showed that we take 5 2's, if we multiply 5 2's together, we get 32, so the top part is going to be 5. And if we multiply by another 2, 32 times 2, we get 64, so the bottom will be 6. So our solution here is x equals 5/6. Hopefully this video was helpful to you. If it was, please like and subscribe. Also, if you have questions, leave a comment in the comments below.